Okay, in this class cast, we're going to be talking about graphs and mathematical relationships. Super important. Okay, so to start, we're going to be doing experiments in physics, and uh, before we begin, there's three very important steps that we need to do in order to set up this experiment. Okay, so the first big one is to brainstorm all variables that could affect outcomes. Okay, so I'll go through this with an example here. Let's say we have a setup, and the goal is to find the density of a fluid. So we have a scale, we have a beaker, and we have some liquid. So what could affect the outcomes of this experiment? It could be mass of the beaker or the liquid, volume of the liquid, surrounding temperature. That could change what the volume is. It could be type of liquid because different liquids have different densities. It could be position of the beaker. Maybe you have to make sure that it's lined up perfectly here. So all these variables could affect the outcomes of the experiment. Okay, and so once we've kind of brainstormed everything that could affect the outcomes of an experiment, what we want to do is we want to select one variable to manipulate, and we call this the independent variable. Okay, so out of these, we need to say, okay, what are we gonna manipulate? And let's say it's gonna be the volume of the liquid, because we can kind of control that quite easily by just changing the different volumes and then see what the mass will be. Okay, so this will be our independent variable. Okay, that could be our independent variable. And what are we gonna observe? Well, for different volumes of a liquid, we're going to see what the scalar reading is. So that would be what we observe is the mass, and so this becomes the dependent variable. And so we have to observe the effect on another variable, which we just chose, while keeping all the other variables constant. Okay, so we have to, in order for this experiment to work, we have to keep all of these things the same between each measurement. Okay, we call this the controlled variables. Controlled variables. Okay, so how would this work? Okay, well, so we get 0 milliliters of liquid, and we have a mass of 0.20 kilograms. Okay, so that's why we have a little, and we plot it right there. Then we select different amounts of volumes, and we measure the mass, so we get all of this. Okay, then what we would want to do is we want to graph it. Okay, so I've plotted the points already, and you have to know how to plot this by hand first, and then I'll show you how to do it with a computer as well. So to start, there's 5 or 6 things that we need to have in every single graph. Okay, first it's the title. Okay, so every time you hand in a graph, make sure it has all these components. It's the title. Okay, the dependent variable goes here, dependent, and the independent, dependent, goes down there. Okay, super important that you label the axes. So labels are super important. And also you have clear data points, and then this is super important. It has a line of best fit. Sometimes it's called the best fit line or the trend line. And when you draw the trend line, make sure it basically represents all your data points. Of course, you're going to do this with a ruler. And maybe you have 1 or 2 points above the line, or 1 or 2 points below the line. Okay, so it's a line it's a straight line that best represents your data. Okay, and so once you draw that trend line or line of best fit, we can determine the relationship between these variables. I mean, that's the whole point of all this. And so what you do is, you first need to calculate the slope of this line, which is rise over run, which you know from math, hopefully. You pick 2 points on the line of best fit. Do not choose any 2 points. Make sure they are on line of best fit. So here we'll choose 0 and 0.2 and 400 and 5.8. Okay, so we'll choose these 2 points because they lie on this line. Okay, if you don't have any points on line, you just have to choose 2 new points. Okay, so to calculate the slope, that's y2 minus y1 over x2 minus x1. And so y2 is 5.8 minus 0.2 divided by 400 minus 0. if I do this in my head quickly, I'm just joking, I already did this, is 0.014. So this is the slope of the line, okay? And then we're not done. We need to take these variables and sub it into the general equation for the line, which is y is equal to mx plus b. Now, of course, we're not using y's and x's anymore. We're using real variables, okay? So you have to sub in for the variables as well. So this equation would become, instead of y, we use m is equal to our slope value, which is 0.014. X, our x value is the volume, okay, plus our y-intercept is 0.2. Okay, so this becomes our mathematical relationship. Okay, that's what we're striving for. Okay, now I'm going to quickly show you how to do this on Excel as well, because that's a very important skill that you need to know. So on your computer, you need to open up Excel. There it is. When you open up Excel, the way this works is, and we'll have lots of practice with this, so don't worry if you don't get it on the first time, but the way Excel works is on the left side you always have to put your X values, and on the right side you always put your Y values. So here I'll start with my label. This would be volume, and the letter would be V. You can make them wider, and the Y variable was mass of liquid, so mass of liquid, and that was in the variable for that was in meters. The letter for that was M. So the volumes were 0, 100. So just type this in, 200, 300, 400, and the measured mass of each of these was 0.2, 1.4, 3.0, 4.4, and 5.8. Okay, and so the way you plot this now, please follow here, is you go, you highlight just the data, not the labels. And you go insert, scatter here. Okay, and you get this nice. Okay, so just get rid of this, make it nice and clean. Get rid of that. Now, you know, computers a lot of nice things for you, but you have to be smart enough to know what the data means and how to make it, make the graph nice. Okay, so of course what we need is a chart title, centered, sure, and this would be Y variable versus the X variable. So this would be mass of liquid versus volume. Okay, that's nice. What else do we need? Well, we need axis titles. So primary, horizontal, below axis. This here we have volume, which was you know, V, and the unit in square brackets is milliliters. Axis title vertical, rotate it, nice, fancy, highlight that, and here we have mass of liquid. Okay, the variable was M, and in square brackets the unit is kilograms. Okay, now the most important thing, what we need here is a nice trend line. Okay, so to do a trend line, you need to go layout, so chart tools, layout, trend line, more trend line options, and then you choose the linear, always choose the linear, and then you set, sometimes we set intercept at 0, 0, but in this case we don't, because obviously it doesn't go through 0, 0. But here you need to click display equation on chart. Once you click that, close, and there you go, you get your nice equation, which you didn't have to do by hand, which is kind of nice. But again, we have to you know, we have to finish this equation. So one thing I would say is we have to change the variable. So y is now mass, the x variable is volume, and this is probably too many sig figs. Well, in this case it's not too bad, but we can take out the one sig fig, so we get m is equal to 0.014 v times 0.12. Okay, you can always copy and paste this chart into Word documents and that kind of stuff. It's really nice. again, we'll get lots of practice with this, but it's really useful, and you'll find it really easy once you do it a few times.